This video is, I think it's Algebra 2. I'm having a hard time tracking which kind of math I'm working on. Algebra 2, I'll say, and it's transforming functions. If I have translations and reflections, if I have a function like this, it's called a f of x minus h plus k. If that's the function, I don't even know if that's the right notation, but it's a f of x minus h plus k. In other words, it looks like this: y equals a times x minus h plus k, where hk is the vertex, and a is some kind of a dilation factor. If it's bigger than 1, it's a vertical stretch. It makes it longer vertically. If a is less than 1, it's a vertical compression. It makes it kind of spread out. It's a horizontal stretch or a vertical compression. So this is about when I'm given a graph. I see a graph, I can look at it, and then I have to write the equation based on that graph. How do I do that? Well, number one, on every graph, you have to know the parent functions, like y equals x squared, y equals x cubed, y equals absolute value x, y equals square root of x, y equals, what am I missing? Log of x. Am I missing any? Y equals 1 over x. You have to know these parent functions. And depending on the course and where you are in the course, it's going to ask you different of these functions. There may be another 1 or 2 that I'm forgetting, but you have to know what they all look like. This one is odd when you're looking for a vertex, but I'll get into that in a second. But you have to be able to find the vertex, the high point, the low point, or sometimes like with x cubed, it's the point of inflection, the point of, am I drawing that x cubed right? Hold on, let me put it here. I'm doing so much. Yeah, I didn't draw it right. I knew I didn't draw it right. It's like this. So that's the vertex, is that point of inflection in x cubed. But anyway, you have to know the parent functions in order to see what hk is. And then you find hk, and then you can pick some second point, some other xy point. You want one that's at the corners of the boxes on your graph so that it's whole numbers, so they're exact numbers, and then plug it in for x and y and solve for a, and then you're going to have the whole thing. I'm going to do a couple examples here. Let me get rid of this. And I've drawn the functions here, but I'm going to do this one first, this linear function. Ax plus 4 minus 7. Let me get rid of the absolute value. Let me put in the line. I know it's called, well, we'll do that one in a second, whether it's b. So on this one, I see a line. What's the vertex of a line? I don't know. Just pick some point. And I'm going to pick one where it's even. But this one, this would be hard to tell, I think. Well, maybe not really hard to tell on a graph you're looking at. Let me see. Yeah, maybe not, because it looks like it's -7.5, but I would like to find one where it's exact. So I'm going to find -7, -1. I'm just going to use that on a line. I just have to pick some arbitrary point. So I've got -7, -1 is the vertex. And here's the equation. I know the parent function is y equals x. So this shifted and dilated function is going to be a times x minus h plus k. H is -7, so it's y equals a times x minus -7 plus 7. And then k is -1, so -1. Now I'm going to pick some other point on this, and you can see here a is going to come out to be -2. I just put it in there as a slider, so normally you wouldn't have, the problem would not tell you what a is, and then you just have to verify it. You have to find a, but in this case, I set a to be something. So I'm going to pick some other point. I want it to be an even point. If you're looking at a graph, you can find this, but I'm going to try to find one here. Let's see. Oh, there's one. -7. Did I already use that one? You already used -7, -1. I'm going to use this point. How about this one? -8.1. So I'm going to use -8.1. The second point is -8.1. That's my point, is -8.1. And so I'm going to plug that in for x and y. 1 equals a times -8 plus 7 minus 1. -8 plus 7 is -1, -1a. equals, I'm going to add 1 to both sides, 2. I'm going to divide both sides by -1. -2 equals a. So see, I did come out with the right value for a. I'll do one more. So again, with a line, you just have to pick some point and call it the vertex. A line technically doesn't have a vertex. You're just picking some point to call the vertex and then pick another point and use those to find that function. Now I'm going to use, I'm going to do the absolute value one. And you can see, I mean, I can see what the function is here. Normally, you're just given a graph on these kind of problems, and you don't know what the function is. I just put it into Desmos. All right, so I'm going to pick the vertex. The vertex is -7, -3, and so I know the function is y, just because I know the parent function equals a times absolute value x minus h plus k. So this is going to be y equals a times x minus -7, which is x plus 7, minus 3. So now I have to solve for a. I'm going to pick some other point on the line, and I want an even point. Let me see if I can find an even point. -6, 2, there's one. You just have to look on your graph, and it'll, whenever you see a point, definitely at the corner of boxes, that's an even point with whole numbers. So -6, 2. X is -6, y is 2. I'm going to plug that in. 2 equals a times absolute value of -6 plus 7 minus 3. And then I'm going to add 3 to both sides, 5 equals -6 plus 7 is 1. Absolute value of 1 is 1, so 1a. So a equals 5. And verified. I mean, that's what I said. I called it B because I had already used A here. I don't think can I do, yeah, I'd have to have the same value. But anyway, I just called it B here, but that's the dilation factor. So that's how you do it. Take the vertex. On a line, you just pick an arbitrary point. On all the other functions, the vertex is defined. It's either the lowest point, the highest point, or with x cubed, it's the point of inflection. Pick that vertex and then some other point that you can get whole numbers for. Use the vertex to get the h and k of this equation, and then plug in the x and y and solve for that a so that you know what the dilation factor is. If it's bigger than 1, it's a vertical stretch. Less than 1, vertical compression.